Assalamualaikum and good day to everyone. Today, I want to share my final year project, which is the synthesis of prenylated hydroxybenzaldehyde and its derivative via Claisen-Smith condensation. My name is Syamin Nurjiha binti Abdul Latif from UiTM Malaysia, and I'm supervised by Dr. Aimee Suhaili binti Saidin. This is one example of prenylated hydroxybenzaldehyde. The functional group that is present in this compound contains of carbonyl, benzene, and a hydroxy groups. Why hydroxybenzaldehyde? Because it is an important key intermediate in the synthesis of various bioactive compounds. For example, macarubicinosin C is one of the bioactive compounds for the anti-eczema, and it is isolated from the leaf of Macaranga species. Next, abicillin 2, which is the active in the medication for breast cancer, is isolated from the Chinese medication plant Prosonitria porfifera. And for the last example is atopilicin C. It is active compound for the eczema, and it is isolated from the leaf of B. draculifolia. Prenylated hydroxybenzaldehyde is one of the key intermediate in the synthesis of various active drugs. However, it is not enough study for this compound. Hence, further study of the inhibition mechanism cannot be proceeded with. For example, macarubicinosin C, a natural compound that can block the action of Staphylococcus aureus, can only be isolated in small amount and lack of concentration from the natural source. A significant study in this project is all the synthetic knowledge from this research may be applied to produce groundbreaking discoveries in science that could lead to the creation of novel chemical entities or drugs. The first objective is to synthesize prenylated hydroxybenzaldehyde and its derivative as an intermediate compound for synthesis of specific drugs. Secondly, to perform Claisen-Smith rearrangement on prenylated benzaldehyde. And lastly, to identify and analyze the synthesis molecule using nuclear magnetic resonance and MR spectroscopy. The expected output first is prenylated benzaldehyde also improve the ability to act as anti-inflammatory pharmaceuticals due to its biology and may be employed to synthesize several additional medication to prevent inflammation in the body. Second, to provide further knowledge on the potential application of the prenylated benzaldehyde derivative in the pharmaceutical and healthcare sectors. Prenylated phenolic, a type of important bioactive compounds, have a prenyl group on the phenolic skeleton. Prenylation has been found on several occasions to modulate the bioactivity of the natural products. The main attraction of this type of compounds is the strong and non-hydrolyzable C substitution of the phenolic system with the prenyl groups. Prenylated hydroxybenzaldehyde, an example of prenylated phenolic compound with an important structure for natural compounds to perform biological activities. According to some of research journals, macarubicinosin C is display a good activity with the IC50 value of 5.06 plus minus 0.21. Drupanin discovered that a prenyl phenolic compounds exhibited the strongest anti-proliferative effects with an IC50 of MCF7, a hormone-dependent breast cancer cell lines. Hydroxybenzaldehyde C has anti-inflammatory properties because it is inhibited vasodilation, migration of new immune cells, and prevent inflammation symptoms such as pain and edema. In my synthesis, it involves two steps, which is prenylation and Claisen-Smith rearrangement. This is a sum of my research from the journal for the step of synthesis. It is different from the base, time, solvent, and another variable. This is my synthetic strategy. First, I react the 4-hydroxybenzaldehyde with a prenyl bromide with a mixture of potassium carbonate and dry acetone for 2 hours at a room temperature, and the yield of the product was 74%. Next, the product underwent the Claisen-Smith rearrangement and the reduction. For the Claisen-Smith rearrangement, the yield of product is 60%, but for the product of reduction, the product cannot be isolated and cannot be characterized. It is unable to be isolated due to the compound's inability to undergo reduction. For its derivative, I'm using vanillin as a starting material for the reaction with the same condition. The G of the product that contains the prenylated reaction is 69%, and for the Claisen-Smith rearrangement, it is 68%. Lastly, the compound that I isolated was characterized using NMR spectroscopy. After complete the reaction and experiment, I'm successfully synthesized an O-prenylated compound and its derivative. Second, successful to obtain the rearrangement product. And lastly, successfully to characterize all the obtained product using nuclear magnetic resonance NMR spectroscopy. To the next research study, my recommendation is to increase the yield of Claisen-Smith rearrangement products using different methods and to study the selectivity of the Claisen-Smith rearrangement.